Hi, this video will continue look at low shear bending diagram coupled with bending flexural stress. So this is a Webwork problem, homework 14 problem 2. Here they give us a beam, have this triangular distribution of the loads onto it, and the first you need to find out the reaction at A and also the moment at A since it's a fixed support. And once you find out, we want to know what is the maximum normal stress. Okay, so for this situation, you need to go ahead and look into find RA and MA first. And then you needed to figure out the low shear bending diagram and see where through there you can find the maximum bending. Right? So that's going to be the first couple of steps. And here I will ignore that. I will trust you to finish that yourself. And then the next is I want to focus on is the compressive stress and the tensile stress. And this cross section, obviously it's a semicircle. And now we know for the semicircle, in order to find the our bending stress, so sigma maximum equals my over I, right? Maximum bending stress, which you find in step 2, times I over I neutral axis. And remember, what will be the neutral axis for the semicircle? It's right here, right? I'm going to use a different color. That's going to be the neutral axis, the centroid going through. And this value here we know from previous statics class, we know that centroid is how much above? 4 over 3 pi, right? And we also know the moment of inertia for I regarding its base, if we call this x. For semicircle, it is 1/8 pi r to the 4th. So knowing that, we really needed to figure out what's the neutral axis moment of inertia. I think we've done that one time before. We're going to use parallel axis theorem, right? So let's quickly review what's parallel axis theorem. Is going to be this new moment of inertia regarding this new parallel axis is going to be equal to I centroid plus area and d squared, the distance between those two axes. However, we needed to really solve the centroid, this neutral axis, because we do not know this, right? This is what we are solving. However, what do we know? We know regarding its base, this value, it's 1/8 pi r to the 4th. It's kind of like a reverse way. And then we are solving this. And then plus area of a semicircle will be pi r squared over 2. And then what's the distance between this neutral axis, the central axis, and this new parallel axis regarding its which is base? It's 4 over 3 pi. That's the centroid. Then that's squared up. So you can clean this up to find out I centroid, right? So that's the first step. You need to find I centroid. You might already have this formula written in your statics book. Okay, so once you have that, that's going to be something you are going to bring up to this formula, bending flexural formula, because that's I neutral axis. Okay, so that's taken care of. So the only thing left for this problem is going to be this y. And think about this semicircle. If it's going through this downward, there's like a downward force on there. So this semicircle is actually going to become, it's going to be bended. I'm going to draw this. This is our semicircle. And this is going to be our neutral axis. So this top section, this yellow section, is going to be compression. And however, this bottom section is going to be in tension, right? So the problem asks us what's going to be the maximum compression. They are asking this top points here. That means the top point. And they ask you what's the maximum tension. It's basically any points along that line. They're going to have the same tensile stress because they have the same Y. Okay, so to solve the top one, the sigma compression will be, we have this max, we already know, and I and A you just figured out for this semicircle, but this Y will be from neutral axis right here to the top. That's going to be your Y, and what would that be what would that be? Because this is, entire length is what? Radius, R, right? That's going to be R. It's going to be R minus this distance right here. What's this distance? 4R over 3 pi. So that's going to be for the top point. That's going to give us compression. How about the tension at the bottom? We're going to have the same maximum because it's at the same point, same location on the beam. And we're going to have the same neutral axis, moment of inertia. What changes is this Y, because this Y is going to be from neutral axis to that bottom points right here. So it's going to be this distance. That's your Y. How far below or how far above? For this one, it's how far below the neutral axis. It's going to be 4R over 3 pi. Okay, so that will help you solve this problem. Hopefully this make it clear for you for any of those irregular shape when you starting to realize it's no longer perfect triangle or perfect square when the top and the bottom is symmetric because you have the same Y, right? However, for this problem, when you have a semicircle, you no longer have the same distance between the top and the bottom. Okay, so hopefully that helps, and I'll see you at the next one. Bye now.